Welcome to your next 8 Caillou challenge called Beginner, Reduce But Grow. Given a non-empty array of integers, return the result of multiplying the values together in order. Example, you are given the array, these square braces denote an array, an integer collection, one containing the values 1, 2, 3, and 4. You are to multiply each of those values and return that product. So we'll go over the absolute beginner way because this is an absolute beginner way video, and then I'll also show you how to do it with LINQ using what I would say is a more advanced technique than a 8 Caillou series. But if you're interested in that, it's good to sort of dip your feet into those waters to start getting some exposure to that. But let's start with the basic way. If you want to pause the video, if you have any experience to try it, go ahead. Otherwise, we'll get into it. I'm going to create a local variable called product to store our result. And note that I'm initializing it to 1 because when we accumulate a product, we start with the value 1. If we started with 0, anything times 0 is 0, right? And we would never get anywhere. Our result would always be 0. So typically when you sum, you're starting from 0, but with multiplication here, that's why I'm starting with the value 1. And then we need a way to get all the values in the integer array, access those, and multiply them to our product one at a time. So you can do that with a basic for loop. This is how we iterate over these data collections. Remember, these use zero-based numbering. In computer science, that's what we do. And before I get too far ahead, this is a terrible name. Let's just call this numbers or something that makes sense to us. Numbers. And arrays have a length property, which I'm accessing here. And then finally, I'm saying to increment the value of the index by 1 each time through the loop. Those are the 3 parts of that style of loop. We'll use the other loops too, why not, just for fun. But you can imagine after we multiply everything together, we can simply return our product for the answer. Remember, as part of the method, it's a contract. People who use it are obligated to provide this information, and we as the method implementers are responsible for returning whatever the return type of the method is. Here it's an integer. So we can say product times equals numbers I. We use the square brackets to access values within the numbers collection. I know it's the same symbol as used for denoting arrays, and that's also what we use to access the elements inside. And you provide a numerical value like this. The loop's nice in that it increments by 1 each time, and so we get the numbers in order. Although you may have noted, it was funny how they worded this. They tell you to multiply the values together in order, but with multiplication, the order in which you multiply doesn't matter. So I don't know why they worded it like that, but there you have it. So something like this should get us what we need. I'll go ahead and test. And attempt to make sure we have everything. And we passed all the tests. If you want to peek at what the basic tests were, you can do that. Let's go over a couple other kinds of for loops, since this is a beginner class. When you don't need the index values, if you just want to go access all the members, you don't really care what specific index you're on at any time, you have some other options for your looping. For example, there's this nice for each loop, and you could say int n, the type is integer, that's why I said that. N, we're just giving it a variable name, which in mathematics is probably the most common name for an integer variable. And then int n in numbers, for each int n in numbers. It reads pretty well, right? And then you could say the same thing, product times equals n. And remember that I used a shorthand here. It's the same thing as saying product equals product times n. And that's just a nice shorthand that we who code a lot use for less typing. And so this is equivalent to what we did before. There you go. And then if you're interested in another little feature, you don't even have to specify the type. So you got this general keyword called var, and it just, you can think of it like variable for each variable n in numbers, and it can infer the type because that's defined here, right? So it can just figure out that, hey, okay, I know numbers is an integer array, so each variable that I'm checking is going to be an integer. And so this would be the same thing. It's not a big deal. This is kind of nice when the type you're using has a long name and you don't feel like typing it out, or if for some reason that type is subject to change, then maybe var is a nice option to use, but you don't have to. And then finally, let's go over, for all you people looking for extra credit, let's do a LINQ example. Using system LINQ, I'm going to bring in that namespace so we can access its methods. And what I tell people to do is keep a page open with the C# documents. Under enumerable, expand the methods. And you're going to scroll through these and try to find something relevant as you work a lot. And over time, you just memorize these. Even if you don't remember how they work specifically, you remember that there's something that does what you want, and then you can go look up the details and refresh yourself. In this case, this very first method, aggregate, you could probably guess from the meaning of that word that it sort of accumulates results. It takes a bunch of data and puts it together. And note that they don't specifically use the word sum. There is a sum in here. You'll see if you just need to add. You could use aggregate to add too, but it's more general than that. It's just sort of combining things. And so you could think of us running a product as combining a bunch of multiplications, right? So maybe, hopefully aggregate, when you see that, triggers something for you, and you can explore it and see if it does what you need it to do. So we'll try a solution with that. I should show, let me go to the top here. Aggregate has a few overloads. When you overload methods, it means they have the same name, but they take different numbers and types of parameters. So you can imagine if you need a little bit different, in a little bit different context, the parameters could be different. So in our case, I like this one, applies an accumulator function over a sequence. In our case, it's just going to multiply integer values. The specified seed value is used as the initial accumulator value. I'm very interested in that. I want a specific value to be used as the seed, or just the starting value that we're working with. I wanted it to be 1, right? So I'm going to opt for this over this one. And then you can see this other overload at the top has extra features, but we don't need it here. So I clicked on the one I wanted, and they'll show you a nice example. If you scroll down, and you can read too, whatever you want to know. And it sort of works like this. You take your integer array, or whatever data you have. It's nice that it matches up. We're working with integer arrays too. You invoke the aggregate method on it. You can do that, by the way, because arrays implement this enumerable interface, the IEnumerable interface. So that's why we're able to call these methods on them. It's generalized, so you can do it with other types of data collections instead of arrays. It's really nice. So we'll follow this format. We'll say ints. We have this aggregate method available to us. Note that you can put your seed value in here, what you want to start, and then you find there are 2 parameters here. You got this right here, this whole thing is a lambda expression. You see with the arrow there, and all it is an anonymous function. Hopefully you can visualize this in your head. Remember the methods, public, static, int, whatever the return type, and then they have a method name, and then they have parentheses with some parameters in it, right? Doesn't that look like a parameter list? And then we use open and closing braces for methods, but bear with this other type of syntax. And then you have the body of your method. So really all it is like they're defining a method in place with just the minimal amount of syntax needed. And that's nice sometimes when you just have a one-off situation where you don't need a fully defined function that you need to invoke a bunch of times. You just kind of a single use and discard situation, and that fits our purposes. So we'll do this. We'll make a lambda. We'll give our seed value first, and then we'll put this lambda expression, and that should have matched the types that they specified for the aggregate overload that we're on. And note that they use some weird syntax here, this keyword. And so I want you to think of this like it's not actually a parameter of aggregate. What it means is that you can call aggregate on something of this type. Right here, this generic IEnumerable. And that's what I meant before when I told you arrays implement IEnumerable. So therefore it qualifies, and you can call aggregate on it. But think of the parameter list as actually starting right here. So we're going to give it a seed value and the function, that lambda expression that we just looked at. They have to be general because this applies to not just integers. That's why they use this kind of verbiage here. This T accumulates a type. It's just think of it like a placeholder, a generic name that could be meant to hold doubles, strings, ints, whatever you can imagine, right? And they do the same thing in the function. They got accumulate, source, accumulate. Just think of it like they're general terms that you can put whatever types you need in there, okay? I know it's difficult to look at first, but that's what we're going to do. So let's do it another way. We did the looping way, which you should know. You got to learn that stuff. But now let's have some fun with LINQ. Numbers aggregate. And then we set our seed value as first. I want 1. I want everything to multiply from 1. And then my parameters, let's call it product to store the result of all these multiplications as we do them. You know, 1 times 2 is 2, then 2 times 3 is 6, store that. 6 times 4 is 24, store that. You know, it sort of multiplies each value at a time. That's how it's going to execute. It executes like that loop we made before, but this is just sort of a nice compact way of writing that once you're comfortable with the code. I don't feel bad if you don't totally follow along. Again, this is to get you exposure. And then for this second parameter here, this is our running product. The second one, we need just a variable to hold whatever number we're looking at any time. So you could call it n, you could call it factor, whatever you think is very descriptive and clear. And then finally, we're just doing the same thing like we did before. We're just saying, hey, take this running product, whatever value you have, and multiply it by each element one at a time. And so something like this should work out the same way. Good, green. So I'll submit mine like this. For 8 Caillou though, make sure you can do the looping okay. And when you get really comfortable with that, start pushing yourself to check out some of this LINQ stuff. Some people overuse it, but it really is nice sometimes. It can be your friend. I'll submit mine like this and see what you can learn. Other people liked aggregate. Apparently you didn't need the seed value there. And yes, check out what you can learn from other people too, as usual. Otherwise, hit me up if you have any questions, or I'll see you in another video. Thanks for watching.